Hi, this is Michael Keller. I'm a product manager with Yokogawa, and today we're going to go over a pressure transmitter calibration with our Fieldmate software. So here is your typical calibration layout for a pressure transmitter. We've got a calibrator here, the CA700 from Yokogawa. It's more accurate than the pressure transmitter we're calibrating, so that's a necessity. It's a 0.01% of reading accuracy, where the pressure transmitter we're calibrating is a 0.055% of span transmitter. We have a hand pump here that's going to be generating the pressure source that's going to be applied to both the pressure transmitter and the calibrator. So the calibrator is going to compare its pressure reading against the pressure reading of the pressure transmitter. And then we have an interface here, a HART modem and power supply that's powering the transmitter and then providing HART communication back to this PC that's running our Fieldmate software, which is our device configuration software that's going to help us facilitate this calibration and our device configuration. So here's the actual layout of a calibration I did. Looks a little kind of messy, but I'm going to try to clear things up with some highlighted boxes to better display the connections that we're doing here. So again, we've got our CA700 pressure calibrator. We've got an EJA110E differential pressure transmitter that we're going to be calibrating. We've got our pressure generating pump that is connected to both the pressure transmitter and the calibrator. We've got our HART modem and power supply that is connecting, providing communication from our transmitter to our PC via HART and also powering the transmitter. Then we have our Fieldmate PC, which will help us facilitate our calibration and also provide us with configuration for our transmitter. These blue arrows are just highlighting how the pressure is going from the pump to the transmitter and the calibrator, so they're connected both with the blue arrows. These purple arrows are highlighting what the modem is doing. So the top two arrows are showing how the modem is providing power to the transmitter via two IC clips in the back of the transmitter, and then also providing HART communication to the PC via a USB port. The calibrator is getting the milliamp analog signal from the transmitter, and this is showing that. The modem actually provides a couple of clips to show the milliamp output from the transmitter. So the calibrator is taking the pressure output or the milliamp output, analog output from the transmitter, and comparing that against its pressure reading. So going into a little bit more detail about the modem, so this is the Power Express Plus. It's kind of unique in that it provides HART communication modem and power supply for a 24-volt transmitter. So right here there's a little switch, so you can either provide HART modem and the power, or just the modem if that's all you need. Also, they have a couple of IC clip ports for if you want to hook an external handheld like a HART communicator, or like we saw in the previous example with the calibrator, the output of the transmitter. So the milliamp analog output of the transmitter you can measure with either a multimeter or, like in the case before, a calibrator. And then this picture is just showing how the modem is physically connecting to the transmitter via two IC clips on the power supply ports on the transmitter. So typically, in calibrating a pressure transmitter, you do a 5-point calibration, so three up or two down, or you might even do a 9-point calibration, 5 up and 4 down. But we're going to do a 5-point calibration today, so 0%, 50%, 100%, and back down to 50 and 0. You go up and then down just to make sure there's no inherent hysteresis or play, so that when you come back down, the 0 doesn't drift. So I've captured some screenshots of the first point that we did. So you can see this is the analog output that we're reading from the transmitter, so exactly 4 milliamps. And then at 0, so both the transmitter and the calibrator are scaled 0 to 100 kilopascals. So this one's pretty much perfect. So we've got 0 kilopascals reading on the calibrator, and then we've got a 4 milliamp reading on the analog output of the transmitter. So our error is 0. So just to skip ahead, if we go to the third point, we've got a little bit of error, but again, the transmitter's reading almost 20 milliamps, and same thing on the calibrator, almost 100 kilopascals. So the error is still well within the tolerance, so the 0.055% of the EJ110E, so it's well within that. So after doing the 5-point calibration, here's our final report from the CA700 screen. So you can see our error is really good, and that's pretty typical of our Yokogawa pressure transmitter. So really, this is just a verification. This calibration, that's all you're doing is verifying that the error is within tolerance. So in this case, you wouldn't have to do anything. You wouldn't have to trim the transmitter or do anything. It's in perfect working order, and you can kind of expect that out of a Yokogawa transmitter. But if it was out of tolerance, we're going to go over and go ahead and show you how with Fieldmate you can trim the transmitter and get it back into tolerance if it was, if your error was outside of tolerance. So when you're trimming a transmitter, I just wanted to go over this, just a general practice. So the main takeaway from this is always do a 0 trim before doing a full scale trim, and this little diagram will kind of explain that. So in the x-axis, we have our pressure reading, or our pressure generated, and then we have so the pressure that the pressure transmitter is measuring, and then we have the output of the transmitter. So ideally, it's a linear device. So at 0 pressure, it should read 0%, and at 100% pressure, it should read 100% output. But there can always be errors, so we're going to go over what those errors are and how 0 trimming and full-scale trimming can affect that. So we can have 0 errors, so that'll affect the offset of the linear line. So if you think of kind of back to algebra, y equals mx plus b, that would be your b value. And then we can have span errors, so that's going to affect the slope of your line. So that would be kind of the m portion of the y equals mx plus b. So if you have a transmitter that's out of tolerance, so it's got both 0 and span errors, we're going to go over why you want to 0 trim before doing a full scale trim, and what could be the consequences if you don't do that. So if I just do a full scale trim, I'll adjust my slope to kind of match the ideal at the 100%, but I still have that 0 error. So that 0 offset hasn't been corrected. So ideally, with a 0 plus span error example, or any time, you do a 0 trim to get your offset, your 0 offset, back online, and then you do a full scale trim to get the slope perfect with the ideal line. So then again, perfect. That's just a good graphical representation of why you always do a 0 trim before doing a full scale trim. So now we're going to connect to Fieldmate to do the trimming that we need to do, because again we're in the scenario that our transmitter's out of tolerance and we need to trim it to get back into tolerance. So we'll pull up Fieldmate on our laptop. So this is kind of the opening screen of Fieldmate. You can save some time a little bit by already picking your communication settings. So we have a Hart transmitter, and I can already see that based on this little display that the modem, so that Power Express Plus has already been recognized. So that Viator USB is the Power Express Plus, and it's on COM26. So I log in. So I just opened up Fieldmate, and it already recognizes my transmitter that I have connected. So its tag is Demo, so that's what it's showing here. It's showing a little icon of the transmitter, so I know it's an EJE. We've got a little indicator light, kind of like a stoplight, so right now it's reading green, so everything's good. If there were some error messages, it would either give a yellow light or a red light. Yellow would be not so critical errors, and then red would be a critical error, like something's wrong with the sensor, or something severe consequences has happened. Then we just have a little bit of identification information about the transmitter. So it's the vendor ID, Yokogawa, the model, so EJA Next or EJE, what revision it is, what the unique device ID is, and whether or not the write protect switch has been turned on. I'm going to come back to these two buttons right here. I just want to show you first. So we've got a sticky note here. So whenever you connect to this device, it'll remember this unique device, and you can put something on the sticky note, whether it's like the last time it was calibrated, any information about the device, maybe if it's in a unique application or just something you want someone to see, you can put that there. And also the same thing with an image. So you can attach an image maybe of where it's installed if it's in a unique place. And whenever you pull up this device, you can know, okay, that's the transmitter at that specific location. And that's another good tool. A nice feature here is this All Parameters button. So if I click that, a printout will come of every parameter set of the transmitter. So what's nice about this, if you're doing work on the transmitter, you can get this printout, export it to Excel or some other type of format, and then keep a log of this, so save this to somewhere, print it out, or you can even create a template for this to populate to create forms about each transmitter. And then you can do this before you do your work and after, so you can keep record of everything physically, if you'd like, about the transmitter. So again, these are all the parameters, and I can export them via text, a web browser, or an Excel table. So that's a nice feature. So again, we want to go in, we've got, in this example, we've got a transmitter that's out of tolerance. So we're going to go to Action and Assign DTM. So with this Yokogawa device, it should automatically assign the correct DTM and pull it up for this specific EJAE. Now these options are asking you for some information. So load from database and load from file are if you have saved configuration files and you want to upload from those if you're trying to replace a transmitter or something. Load default data is actually live data from the transmitter, so we're going to go with that. So I've got the main menu here for the transmitter. You can see, we've got our process variables. So these are updated, every few seconds to show you your pressure percentage. So percentage of span, what the actual pressure reading is. So that's differential pressure. The static pressure. So again, what's unique about Yokogawa's DP harp sensor, it can measure DP and static pressure simultaneously from one sensor. So we've got that as well. And then also sensor temperature, so the temperature of the sensor inside the capsule. So that's just a diagnostic. And then also we can see more details of any diagnostic. If there's any alarm, they would be blinking in red over here on the right. And you could see in detail what specific failure there is. So again, we want to trim our transmitter. That's our ultimate goal after doing our calibration that we found was out of tolerance. So if we go to Configure, Basic Setup, I'll just show you this first. So again, this is a good place to do just all the basic things needs to be done with a pressure transmitter. So if you want to set up your tag, rearrange your transmitter, set up your units, set up your transfer function, maybe to square root if you have a flow application, a DP flow application, your damping. So all your typical parameters are set here. In detailed setup, We can set up the display so you can have it read pressure percentage. You can have it read the actual pressure. You can have it read static pressure. You can have it cycle through all these things. So there's a lot of options you can set up with the display. But again, we want to do our trim, so let's go find that. So under Diagnostics and Service, and under Calibration is where you'll find the pressure trim. So we're going to go to Pressure Sensor Trim. So right here we have our values that the capsule is set to. So again, we scaled it to 0 to 100 kilopascals. And then we have our trim information. So right now this transmitter has not been trimmed, so no values have been adjusted. So again, we're going to do a 0 and a full scale trim. So if I go here to pressure trim, so again, I'm going to do auto lower point, so that's your 0 trim, or your lower scale trim. We're going to do auto. Manual allows you to adjust it manually, so you can, like let's say you're on the high end, you're reading 100 kilopascals, and you notice on your calibrator that the calibrator is measuring 102 kilopascals. So you'd have to do, for manual, you'd have to do the math, 2 kilopascals, and make that adjustment that way. Auto allows you to just take whatever you're reading on the calibrator and trim to that. So if it's reading 102, you put in 102 on this this trim for auto, and it makes the adjustment. So we're going to do auto lower point. Okay. And again, so our pressure transmitter is reading negative 0.56, so that's what the actual transmitter is reading. And then you would put in, if you're hooked to a calibrator, you would put what the calibrator is reading in this field, so to make your adjustment. So in this case, my transmitter is open to atmosphere, so I will go ahead and make this trim. So we've done our lower, so we've done a 0, so we want to do our upper. So again, the transmitter is reading 0. Ideally, you would have a calibrator hooked up and a pump, and you would apply that 100% pressure a little bit higher, and then you would look what it's reading up here, and then you would take the calibrator value and you would put the calibrator value down here. So that's how you would make that higher trim adjustment. I don't have a calibrator hooked up right now, so I'm not going to. I'm going to go ahead and abort this, but it'd be a similar process to the lower trim. So again, now we can see in the pressure trim info, we can see that lower trim adjustment that I made because the transmitter was reading a little bit negative, so it kept record of that. One nice thing about Fieldmate in the Yokogawa pressure transmitter is if you make a trim and you make a mistake, you can reset it back to factory settings with this button, so clear pressure sensor trim. So when I do this, it will return the trim back to what the factory originally set it. So if you make a mistake, it's not a big issue. Okay, so we trimmed our transmitter. That was the big goal after doing the calibration. So one last feature I want to show you with Fieldmate is saving configuration files. So all of this part of Fieldmate has all been in this online menu, so this online parameter screen. So every adjustment I've made or would have made is happening in real time because I'm connected to the transmitter. What we can do is we can go to Device and Offline Parameter and make adjustments offline. So I've got this workspace here. So again, we're offline, so nothing's, except for the tag, has been populated. So I want to upload from my device. So that's going to get all the variables from the transmitter I'm connected to. So I'm going to copy all these parameters into my workspace. So the workspace is where you can make adjustments. So if you wanted to, instead of making changes point by point, you could make a lot of changes in this list because every parameter is listed, and then just adjust it that way. So I'm in my workspace. Let's change something. We'll change this to 90 kilopascals. And we'll change the transfer function to square root. So what I can do is I could download this to device, and then it would make the changes. All the, every parameter would be updated. But what I'm going to do is, instead of doing that, I'm going to save this configuration file. So once you've created a device that maybe you want to copy to another device, if you have spare transmitters or you get a new transmitter, you can save configuration files and apply it to new transmitters. So I'm going to export this configuration to a file. So it's a CSV file, so you can open it up in Excel and look at it. We'll just call this test. So I'm going to save this. So that's saved. What I can do is I can just make a change. Let's go back to 100. So this hasn't been downloaded to the device. What I can do is import that file that we just created and make sure it gets changed. So again, I imported it, and now we have 90 kilopascals because that's what our file had. So again, if you had an off-the-shelf unit and you want to throw in your typical, for a certain application, your typical pressure transmitter configuration, you can keep files of everything and then load them into a new transmitter. So we'll go ahead and download this to device and change that span. And it takes a little bit longer because every parameter is being adjusted. Unlike in the online menu where it was just point by point. It's a little bit quicker. So now we can see in the menu that it's been changed to 90 kilopascals. So that file did take. If you have any more questions or would like more information about Fieldmate or any other Yokogawa product, please visit our website at yokogawa.com/us. Thank you.